Hi everyone and welcome back to Knowledge Doctor. Today we are diving deep into Meta AI brand new backthrow REFRAG, an upgraded version of the classical RAG system. So if you have wondered how the large language model like DeepSeek or the Llama find the accurate answer from tons of document. So this video is only for you. In this video you see that the difference between the RAG versus the Meta AI's REFRAG. If you are new to my YouTube channel and just click the video for the first time, so please subscribe it and hit the bell icon. Also, if you want to build here Gen AI project from scratch, you can also follow this series. So I'll attach this link in the video descriptions. You can easily get it. So here you can see that you already built here 90 projects. You can easily use them. Also, you can see here it also have the rack project. You can see Amazon Finance rack system using Pythons and the LangChain. Okay. So now let us start our tutorial right now. So the very first question is arises, what is RAG actually? So let us start the traditional RAG pipeline. So RAG means Retrieval-Augmented generations. So imagine you ask a question called, who built the Taj Mahal? So the model does not memorize the entire internet. It cannot. Instead, it searches some relevant text chunk from a database. See, from a database and use them to from an answers. So this is basically the RAG. What is actually RAG? Now let's see the explanation, step by step explanations. So first one is encoding and document. So what you need to do? First you need to encode here and documents. Now see, our large language model is trained on vast amount of data. Now if wanted to ask some questions that is become personal or about my company, so the large language model don't have the information of that. So what you can do, basically we can add some document on that. So it's called the document encoding, or you can say encoding documents. So additional documents are encoded using an embedding model. You can see using an embedding model. So which turns into the numerical vector, because we know that computer does not understanding here the textual data. It just understand the number. So what this embedding model actually done, it will try to convert them into some kind of numerical vector. Now the second step is called a vector database. You can see it chunk from a database. It's mean that it's chunking the data from the vector stored database. So that's embedding vector are stored into an vector stored database for the first similarity score. See, for the first similarity score, because you can see that the model does not memorize the entire internet. Instead, it searches some relevant text. So here it can find in the vector stored database. That's what you can see for the first similarity search. Now, third step is called user query embedding. Now, user can ask a question. See, who built the Taj Mahal? It's a user query. So here a user asks a question, that query is also encoded into vector. Same thing, who built the Taj Mahal? It's also passing into the embedding model and it will convert them into the numerical vector. So two things, one is the document, it can be the PDF, it can be docs, it can be the textual data. I mean the TXT file. So what it can do, it will first convert them into the embedding vector, as well as it will store them into the vector database, and then it will also taking here an user query and also convert them into the vectors or the numerical representation of the vectors. The fourth one is similarity search. See, similarity search. So this system find the most similar chunks. Chunks mean pitches. Chunks mean pitches. So to try to find some most similar text chunk from the database. Then after that, you're creating here and prompt creations. These chunks are added to the prompt and sent to the large language model like DeepSeek or the Llama. It means that first you need to encode the document, you need to store it into the vector store database, also the encode the user query and try to find some similarity chunks based on some kind of chunks, and then you need to also pass it to the large language models. Now, after that, the large language model generate a final answers using the both retrieval chunk, see both retrieval chunk and its own knowledge it have. Okay, the own knowledge it have the large language models. So RAG actually helps the large language model to stay up to date and accurate, but it has a weakness. See, it has a weakness. That's why Meta AI, the breakthrough is coming up, the REFRAG. It treats every chunk equally and does not understand which part of the text really matter for the which question or for your questions. That's also one weakness, very weakness. So if I see the picture that you can see the rack additional document, it's also encode and passing to the embedding model that you can see, and then query is also passing. Okay, now based on that it will give you some kind of numerical representations, as well as you can see here it encoded and store it inside a vector stores. Now, based on the query, it will try to finding some of the similarity score. See similarity sets, and this chunks is passing inside the and that is actually stored inside the vector stores and also the chunks. Now, based on the chunks, it will passing the prompt. You can see prompt creations with a DeepSeek R1. Now, after that, we got some final response. This is how the RAG system actually work. Okay. Now, what about the Meta AI REFRAG? So, Meta new model REFRAG solved this by making retrieval smarter. Retrieval means retrieving something from the database. So it doesn't just match the embedding, it understands relevant at a token level and filtered chunk using a lightweight reinforcement learning policy. The most important part here, lightweight reinforcement learning policy also at token level. See, token level and filter chunks. It will filter the chunk. It's not going to search in the similar score just like the Euclidean distance. Okay. So let's see the step by step breakdown. So you can see here, first one is a document encoding. Same thing, you need to do that. So just like the RAG, documents are encoded and indexes in a vector database. Then the second one is user query encoding. You can see user query encoding. So the entire user query is actually encoded. Two things. One is a document. Another one is a user query encoding. Third one is token level and embedding. See, the most important one. Instead of treating chunk as a single block, because you know that if I see the RAG, so this chunk is treated as a single block. Now in here, you can say that instead of treating chunks as a single block, the REFRAG break them into smaller token level encoding. See, token level encoding. Okay. This is the main things happening in the REFRAG, and there's a difference between the RAG and the REFRAG. Third one is chunk relevant check. See, chunks relevant chunks. So each chunk is passes through an reinforcement learning train policy. Reinforcement learning train policy that decide which chunks are actually relevant. Which chunks are actually relevant. Then after that, it will merging the embedding. So relevant chunks are merged with token level details is preserved, which is basically preserved. And after that, it compresses the chunk embedding. So that's refined the context our embedding are then passed to the large language models. That's why it's quite that's why it's quite updating things, right? And final response, the large language model is generating a more accurate and the context is answers. So instead of throwing all similar text to the large language model, the REFRAG carefully pick the most useful information, just like a human researcher who read and filtered before the answerings. But if I see in the RAG, it will passing all the documents. So which one is also the costing. It's also taking the memory, right? So, but in the case of REFRAG, it will try to carefully pick the most important most useful informations. So if you see the picture, you can see REFRAG, you can see the additional docs and code and model, vector database, the similar chunks is passing to here, and lightweight RL train chunk relevant policy. And you can see it's passing to the large language model with token level merging and the lightweight reinforcement learning chunks relevant policy. And then DeepSeek model is also give the final response. So those are the basic difference between the RAG and the REFRAG. And if I go down, so RAG versus REFRAG. So in short, RAG retrieves similar chunk based on some general embedding. See, general embedding. The REFRAG retrieve relevant chunks based on token level understanding and the reinforcement learning. Two things, token level understanding and the reinforcement learning. So this means fewer hallucinations. So we don't know that what is the hallucinations. No problem. I also coming up with a video about the 12 known GNA terms. Okay. So more precise answers and the less computational waste, because in the case of RAG, it will try to fitting all of the documents inside the vector database. It try to finding the chunk from it, but in here it will try to finding the lower chunks. Okay. Now why this matter? So Meta's REFRAG could redefine how the large language model especially interact with some external knowledge. So it basically bridges the gap between the retrieval and the reasoning that you can see. And it basically making the AI system not only for smarter, but also more some context aware. Also, this can also revolutionize the chatbot, the medical assistants, the enterprisers, and also the education system. So you're already creating here so many videos about the RAG, that how you can basically create that. So now it's time to also creating here a video about the REFRAG as well, because I found it interesting. So basically that's it from my side. That's the basic difference between the RAG and the REFRAG. So If you learned something new today, so drop a like and subscribe to the Knowledge Doctor, and let me know in the comment box. So what topic you want to next? So maybe the breakdown of the DeepSeek or the Gemini retrieval flow. Which one? Let me know. Okay. So thank you and bye bye.